We're going to subtract these rational expressions. X plus 2 over x minus 1 minus x squared plus 6x plus 8 over x squared plus 4x minus 5. Now, to illustrate why we do this the way we do it, I'm going to show you with a couple of arithmetic examples alongside. So, similar to this question is if I had 3 over 7 minus 3 over 35. So here I've got a fraction minus another fraction. They happen to be of polynomials. Here I've got a fraction of integers minus another fraction of integers. Now, to make it clear what I have to do, I'm going to factor everything here. I have mostly prime numbers, so that's just 3 over 7. But this is 3 over 7 times 5, because 7 times 5 is 35. It is now very clear that if I multiply this top and bottom by 5, I will have a common denominator. So I will multiply this by 5 and that by 5. Now I've got the same number on the bottom of each of these two fractions. And I'm going to do exactly that with these polynomials. So to start out, I want to factor everything on the right. So we've got x plus 2 over x minus 1. And I need numbers that add to 6 and multiply to 8. So that is x plus 4 and x plus 2. Over on the bottom, I need numbers that add to 4 and multiply to minus 5. And those are x minus 1 and x plus 5. 5 minus 1 is 4. 5 times minus 1 is minus 5. Now, do you see how in this case we had 7 times 5 on the bottom here and 7 on the bottom here? So we created a common denominator by multiplying top and bottom by 5. If you look here, we have x minus 1 times x plus 5 here, and we have x minus 1 here. So to create a common denominator, all we need to do is multiply this term top and bottom by x plus 5. It's perfectly fair for me to do that because x plus 5 over x plus 5 is equal to 1, as long as x is not equal to negative 5. As soon as this is factored out, we should state our restrictions. Clearly, x cannot be a 1 or a negative 5. Because if x was a 1, we would divide by 0, and if x was a negative 5, we would divide by 0. Now we can, well, I'll show you again with the numbers. So once this is done here and we have a common denominator, we can write the difference of the numerators over that common denominator. So we've got our 5 times 3 minus 3 all over the common denominator of 7 times 5. 5 times 3 is 15. So we have 15 minus 3 all divided by 7 times 5, which is 35, giving us 12 over 35. I'm going to do exactly the same thing, but just with these polynomials. So remember the first step, we're going to write the difference of the numerators, that's the tops, over that common denominator. So our common denominator is x minus 1 times x plus 5. The difference of our tops is x plus 5 times x plus 2 minus x plus 4 times x plus 2. We can then expand, subtract to simplify, look for something to cancel out, and then put everything in standard form. So I'm going to expand this out. This is x squared plus 7x plus 10 minus x squared minus 4 and 2, that's 6x, and minus 8. And all of this is over x minus 1 times x plus 5. Now we could expand this out as well, but then we're just going to factor it afterwards, looking for a factor to cancel. That's why I'm leaving it for now. Now we're going to simplify the numerator. The numerator is x squared minus x squared, so that's 0. 7x minus 6x, so that is x. And 10 minus 8, so that is plus 2. And our denominator is still x minus 1 times x plus 5. As you can clearly see now, there are no common factors in the numerator and the denominator. There's nothing to cancel out. So we can write the bottom in standard form. We've got x plus 2 over x squared plus 4x minus 5. That is 5x minus x is 4x, and minus 1 times 5 is minus 5. And we have the restrictions that x cannot be equal to either 1 or negative 5, because if it was, we would have a 0 here if it was a 1, or a 0 here if it was negative 5.